Alright, we're going to demonstrate some of DataLink's workflow management capabilities today. We're going to start by logging into the system. I'm using a fake badge called My Badge. Normally we just use a simple HID card or in a reader to enter that in. Second, we want to enter a part number. We're going to match the part number up with a SKU and then add it to a customer. This can be all done programmatically if we want to. We're going to make up a part S123456 to start tracking it through the system. And we'll go to step 1. Step 1, we can see the logout button, the override step, and override station. Logout simply takes us out of the system so that we have to swipe back in. It'll pick back up where it left off because the part is still assumed to be at the same station. We can take the part off the station by clicking override station. We can also look at how the step is made up. We can drill down into the step in the management platform and see all the components that make up the step. The image, the template that we use, the text pattern. We'll zoom into the text pattern so you can see it. And the title, which for the sake of the demo we just named step 1. The system also gives us the ability to preview the slide live by just clicking a preview button. This is what it'll look like. So now that we know that we've got something going, we'll go back to the screen and see step 1. Now we can just move forward using our remote, using a simple remote via Modbus. So we can use any kind of button really to make this work. Now that we've advanced through several steps, we can see how long it took us at each step. We completed steps 1 through 3. You can see how much time we spent on step 1, steps 2, and step 3. And right now we spent 0 time on the rest of the steps. And we start adding this up with everything else throughout the course of the system. And now we're going to advance through a couple more slides to where I know we're going to need to pick up some of the assembly lubricant. And the step is going to actually ask us to validate the SKU of the lubricant that we're using. I happen to know that the SKU is RP321. This is typically done with some kind of scanner against a barcode. The screen turns red when it's scanned wrong, and it'll turn green when it validates. And again, we're keeping track of the time spent on these steps on the management platform as well. So we'll continue stepping through some more steps, not taking any time on them. If you want to read what it says, you can stop the video, pause the video at any time. But we really only want to demonstrate interlocking the system with certain gates. And once we get up to step 19 or 20, we'll be asked to torque a couple of bolts. Alright, here at step 20 you can see the picture of the bolts and the bolt pattern that we selected. We want to torque the bolt that's highlighted in blue first, and the one that's in gray will come second. And we're going to use a torque simulator for this, so we're not actually going to achieve 73 foot-pounds, just enough to let the screen advance and turn green like it did for the SKU validation. Notice that the dots moved. Now we want to torque the bolt on the right. We torqued bad first, it went red, and then it turned green and went to the second bolt pattern. Now we're going to demonstrate overriding the step. This will be shown in the part history later. So we'll click override step and give a reason. Tell it we're simulating the torque. This goes into the part pedigree as well. And we skip the step and go on to step 22. And now with our remote, we can simply skip backwards and redo the step if we want to, so that we can get good values in the system. And this will happen the same way that the first torque step occurred. Now on to step 22. and we'll just ignore the rest of the torques for the demonstration. And there's only 26 slides total. Now, once we finish the part, we can go refresh our pie chart here and see how long it took us at each step. We can also average this out over the last several days to see how we're averaging on times as well. We're all recording this based on how long each part stays at each step. We can also graph it via station. This will also export to CSV if you want to use it in Excel or some other data sheet, spreadsheet program. Now we can look at the production history for the part. We'll type in a date range that grabs today. And we'll pull up the 2 parts that I've run today. And we'll select the one that we just ran. We can right click to view all the production history and see all the recorded values that we got. And this brings up our production history. There's a good bit of information down there. You can see that we scan the part into the system. Each step, once it's completed, we tag it. We also tag that we scanned the wrong component twice. And then once we completed step 20, we went to step 21, then overwrote it, then stepped back to step 21 and completed it. We also recorded the torques and the angles and the cycle results from the torque driver as well. This can also be exported to Excel. Now we can pull up a nice PDF of all the components that we may have scanned to the part and all the individual torque values that we made. So here's our production control plan report. We can filter it by any category that we wish. That's all dictated in DataLink in the background programming that we may put into the system. It's completely customizable at installation time. No extra programming is really needed. We can export this to PDF, pull it up in Adobe, and send it to the world if we want to. This pretty much concludes the demonstration. We're always adding new reports and features to the back end of this because the information is very useful.